Hello everyone, and in this video, I'm mostly going to talk about the runtime environment of Pypy and how that is different from that of Cpython. How specifically Cpython works, how are the interpretation steps, how does entire thing gets compiled to the bytecode. We have already seen onto the previous video. Now, how to basically your Pypy runtime environment that's different. If you look on for its PVM, its Python virtual machine onto the runtime environment of Pypy that does have a component what we call as the just-in-time compiler. What does it do basically? It identifies most frequently executable code. What are they? Suppose that you are having a method in Python that are being called with the same value of arguments 10 to the power 6 times. A huge number of times the same function is getting executed. In other sense, if I just try to talk about it, then such kind of code snippets your JIT identifies. Correct. And rather than executing the same code onto the interpreted manner, that is your stack based execution again and again, right? It tries to compile it to the machine code. And the compiled version is being stored somewhere called as the JIT cache. That's a specific area of your RAM wherever such kind of machine codes are being cached by your JIT. And after a few executions, right? After for a first few times, let's say the specific method, whatever you are executing, what is mostly frequently executable code for me, that will be executed with the help of stack-based interpretation only. But once the frequency has been identified by your JIT, uh, the overall execution strategy changes. Your specific execution engine, right? It switches back the execution mode from stack-based to CPU-based. Now, the overall identification of the machine code would be happening from the JIT cache. CPU is going to execute that directly. And this specific CPU-based compiled code execution is much faster as compared to that of stack-based interpretation. Okay, so such kind of JIT-based optimizations has been taken by your Pypy runtime environments. Now keep on to the fact a few things. What is it? Pypy is not compatible with everything that specifically your Cpython supports. So what kind of thing are they? So if you look on for C-based libraries, whatsoever Python has, just like your NumPy, Pandas, correct? Pypy is not that compatible with such kind of libraries. And the execution of such kind of code snippets, what are specifically dependent upon NumPy, Pandas, etc., right? Thus, this specific execution speed is slower in Pypy as compared to that of your Cpython. Do keep that onto the mind. Also, if your script is smaller, let's say, of your script is smaller. So in such kind of scenarios, the JIT based execution, whatsoever Pypy looks on for, right, that adds a overhead. This adds an overhead, while Cpython can instantaneously run such programs, what are smaller in nature. So there are pros and cons associated with each kind of runtime environments. Still, if you go for multiple kind of applications that are running with the help of Python, Cpython is the way to go for a large number of application, right? New runtime environments are also being introduced, but going to the fact how Pypy is different, this is one of the key differences we can have. Going forward onto this series, I can bring insights over how specific versions and what kind of more Python, such as restricted Python, are dealing with multiple other scenarios. And that would be quite later once we discuss the core points of Python. As of now, let's keep the discussion till here. And next, I'm going to mostly talk about how data types, variables, loops, etc. works in Python. And specifically for interviews, right? What nitties and gritties we are required to know. Thanks all. If you like this video, please like, share, and subscribe. Thank you.